Hey, this is our second video. Today, I wanted to do large-scale wind patterns. So, large-scale wind patterns, let's see, there's something called the Coriolis effect. And what the Coriolis effect is it's wind caused by the spinning of the globe. And when the globe spins, it creates air movement, which is wind. So if you see in the picture I gave you, the upper air has the arrows indicate the wind direction. So they're kind of going opposite directions. Let's focus in right on the equator by looks like Brazil. The wind is all traveling right down to the left along the equator, which is essentially saying wind comes from Africa to Brazil. So a large-scale wind pattern is Brazil gets a lot of its winds from Africa. So let's go into that a little bit. Let's see here. So here's another picture of it. We have this picture, it's Africa, and it's showing the northeasterly trade winds and the southeasterly trade winds traveling along the equator, pushing the wind towards Brazil. Let's see if we can find another picture. Here's another picture. The H's and L's stands for high pressure and low pressure. So this big L up on top of Greenland is low pressure. That means cold air and possibly wet. Cold, wet air is low pressure and that sinks. H is dry, hot air, and that rises and spreads out. And the different temperatures can cause wind to move too. Hot air rising, cold air sinking, that causes wind movement. But essentially, even with the H's and L's, the wind is moving in a similar direction to the first picture. This is a little bit more zoomed in. So there's some slightly different patterns, there's some circles and things. But the main concept I want you to get is that wind is coming from Africa to Brazil and specifically into the Brazilian rainforest. If you look along this red dotted line, the wind is coming into the Brazilian rainforest. Let's see. I have a short video. Let me play this short video for you.
Largest desert.
So the dust from the Sahara Desert gets blown by wind to the Brazilian rainforest, which does two things. You can look at it in a satellite, so you can see that it's see the wind pattern just from the dust. But the dust is bringing two things. It's bringing phosphorus to the rainforest. It's bringing a mineral that the rainforest doesn't have. And it's also bringing rain. It's bringing rain because water molecules, as seen in the picture, have a slight charge like a magnet, positives by the hydrogen and negatives by the oxygen. And those water molecules bond extremely well to dust particles. So when water molecules bond together, they create a long chain like this. But when they bond to dust, they create a giant mass of water. Let's see if I can show you. Show you a picture of that. Here we go. So microscopic dust particles help things like rain and snowflakes grow because it's allowing many rain molecules or snowflake molecules to bond together and create one larger droplet. And that larger droplet means more snow and more rain. In the case of the Brazilian rainforest, it's more rain. Here's some large-scale wind data for the US. This is at 80 meters high, which is roughly 240 feet high. And so it's pretty high. It's above all the buildings. It's above all the trees. So it's showing kind of the global patterns of wind. So as we get down lower into the mountains and the trees and the buildings, the winds that are at those heights are a little different than the winds that are at higher elevations, higher heights. So this map of the US shows that the heaviest winds are in the Midwest. And that that is a function of the mountains, even though it's at 240 feet high, which is not above a lot of the mountains. This is basically showing what the wind that is. It's showing an area that's funneling wind. We have many mountains out west. We have mountains on the East Coast, and those areas kind of block the wind. Whereas in the Midwest, we have winds coming right through. So basically, if you were to ask me the best location in the US to put wind turbines, I would say the Midwest, Iowa, Illinois, Kansas, Nebraska. Those are all great states for wind turbines. And Kansas has many wind turbines. Kansas is full of wind turbines. So those are good locations for wind. That's solar. Okay, so I think that concludes global wind patterns for today.